Hey everyone! Welcome to Mastering 2Sum, a coding challenge essential. Take a look at the title. This one's a classic problem that teaches how to think like a programmer. Imagine you have a small list of numbers, say 2, 7, 11, and 15, and you're asked to find two numbers that add up to 9. Sounds simple, right? But when you start writing code, you'll see it's actually a beautiful little puzzle that teaches you logic, efficiency, and how to think in steps, like a real developer. By the end of this session, you won't just know the answer, you'll know exactly how and why it works. Let's start with understanding what the problem actually says. Alright, let's look at this slide together. It explains the problem clearly. You're given something called an array, that's just a list of numbers. Here's the array, 2, 7, 11, and 15. And you're also given a target number, which in this case is 9. Now, your goal is to find which two numbers in that list add up to 9, and return their positions in the list, what we call indices in programming. So let's check. 2 plus 7 equals 9, that's our pair. Their positions are 0 and 1. So the output would be those two indices, 0 and 1. And there's one simple rule: you can't reuse the same number twice, and there's always exactly one correct pair. That's it, that's the entire challenge. Small, simple, but extremely powerful for learning how to solve problems logically. Now, let's see why this particular challenge is worth learning. Okay, take a look at this slide, it answers the why. First reason, it helps you understand core programming concepts like arrays, loops, and hash maps. If you're learning to code, these three tools will show up everywhere. Second, it builds your sense of efficiency. You'll start with a simple, slow solution, and then learn to make it much faster and cleaner. That's real-world coding right there. And third, this problem is a pattern builder. Once you learn this, you'll recognize similar logic in other problems like three numbers that add up or closest pair. There's a quote here that I love: efficiency is intelligent laziness. And it's true. Great programmers don't just work hard, they work smart. Alright, let's take that mindset and move to the step-by-step process. Here's our plan, and it's shown clearly on this slide. Step 1, start with brute force. That means checking every possible pair of numbers to see if they make the target. It's simple but slow, like checking every combination at a party to find two people whose ages add up to a certain number. Step 2, optimize using a hash map. Think of a hash map as a digital notepad. We'll write down the numbers we've already seen and their positions. That way, we can check instantly if we've already found a matching number. Step 3, one loop only. We go through the list once. For each number, we calculate what's missing, the complement, and check if that complement already exists in our map. If yes, boom, we've found our pair. And step 4, handle edge cases. What if the list is empty, or there are duplicates, or negative numbers? Good code handles all of these gracefully. And that's our roadmap, from slow and basic, to elegant and fast. Now let's bring that plan to life in JavaScript. Alright, this slide shows the full code for the optimized approach, but don't worry, I'll explain every line in simple terms. Line 1, we start with function 2Sum with inputs nums and target. That means we're creating a function named 2Sum that takes a list of numbers and the target value we're looking for. Line 2, we write const map equals new map. This creates an empty map, our memory notebook. It'll remember each number we've seen and where we found it. Next line, we write for let I equals 0, I less than nums.length, I++. That just means, loop through every number in our list, one by one. Inside the loop, we calculate complement equals target minus the current number. If the target is 9 and the current number is 2, the complement is 7, because 2 plus 7 makes 9. Next, we check if the map already has the complement. In plain words, have we already seen the number that matches with this one? If yes, we've found our two numbers. Inside that check, we return both positions, the one where we saw the complement earlier, and the one we're looking at now. If not found yet, we add this number to our map, so that it's remembered for later when we might find its match. And if we go through the whole list without finding a pair, we return an empty result, meaning no match found. Example time: our array has 2, 7, 11, and 15, and the target is 9. When we reach the number 7, we'll notice we've already seen a 2 earlier. Together, they make 9. So we return the positions of those two numbers, 0 and 1. And that's it, one loop, one map, lightning fast performance. Let's see how this logic works visually. Here's what's happening behind the scenes. We start by creating the map. It's our notebook to store numbers we've seen and their positions. Next, we loop through the array. We only go through the list once. For every number, we ask, what do I need to reach the target? That's our complement. Then we check the map to see if that complement already exists. If it does, perfect, we've found our pair, and we return both positions immediately. If it doesn't exist yet, we store the current number and move on. This is what makes the solution efficient. We're not checking every pair manually, we're simply remembering what we've already seen and checking against it instantly. And as the note at the bottom says, maps are super fast for lookups in JavaScript, so this method is both elegant and quick. Now, let's test this with some examples to see how it performs. Alright, here's where it gets fun. Let's walk through a few examples together. First example, the basic case. We have a list with the numbers 3, 2, and 4. Our target is 6. Let's test combinations. 3 plus 2 is 5, not enough. 3 plus 4 is 7, too high. 2 plus 4 makes 6, perfect. So the result is the positions of those two numbers, 1 and 2. Second example, duplicates. Now our list has just two numbers, 3 and 3. The target is 6. Both numbers are the same, and together they make 6. So our answer is the first and second numbers, or positions 0 and 1. Third example, negative numbers. The list is -1, -2, -3, -4, and -5. The target is -8. If you try -3 and -5, you get -8. So those two make the perfect pair. They're at the third and fifth positions in the list. And that's how it works, the logic stays the same no matter what the numbers are. You can try these examples in your browser or code editor, you'll see how fast it finds the matching pair every time. Now let's wrap it up with a few key takeaways. Alright, we've reached the final slide. Let's summarize everything we've learned. On your screen, you'll see three main ideas: start simple, hash maps win, and practice makes perfect. First, start simple. Don't rush straight to the optimized version. Start with the brute force approach to really understand what's happening. Second, hash maps win. They make your solution efficient by storing what you've seen and helping you find matches instantly. And third, practice makes perfect. Try solving similar problems like 3 numbers that add up or closest pair. They're just variations of the same logic. And here's something to remember: coding isn't just about syntax or writing functions. It's about thinking step by step, building logic, and solving problems in the simplest way possible. So take a moment, you just learned one of the most useful problem-solving techniques in programming. You're not just writing code, you're thinking like a developer. That's something to be proud of. Alright, great job today, keep coding, keep exploring, and remember, Every line of code you write makes you a little better than yesterday.